Good morning, students. Let us discuss about the new topic, reflection of light. In last period, we already discussed about the wave nature, different theories which are related to the light. For example, corpuscular theory, Huygens wave theory, Huygens principle. Then let us discuss about the reflection and refraction of light from the plane surface. In 9th or 10th standard, we already discussed about the reflection of light from the plane surface, refraction of the light from the transparent medium. Then, what is meant by the reflection? Reflection means when the light or light beam is incident on the surface, reflecting surface like plane mirror or the polished surfaces. Then, when the light is incident on these reflecting surfaces, then this reflecting surface sends back the light beam in the same medium, and this phenomena is called as the reflection of light. Then, for this purpose, consider this XY is the reflecting surface. Now, here it is considered as the mirror, that is the plane mirror. This is the incident ray PA and another incident ray QC. These are the two rays are going to incident on this plane surface, that is the mirror. This PQ is called as the incident wavefront, as point P and point Q are in the same phase. Now when this PQ, this is the incident wavefront, it goes in forwarding direction. Initially, this wavefront meets at the reflecting surface at a point A, whereas this B point does not meet on this plane reflecting surface. Then, when this PQ is converted into this incident wavefront AB, and when this incident wavefront AB is incident on this reflecting surface, then at this point A act as a secondary source of light. We know that the Huygens principle, every point on the wavefront acts as a secondary source of light and it emits secondary waves or secondary wavelets in the forward direction. Then consider the time t. In this time t, when this wavefront moves from point B to C, when this wavefront moves from point B to C in a time t, if v is the velocity of light, if v is the velocity of light, and when this wavefront moves from point B to C, this length of path BC is equal to V into t. As we know that velocity is equal to displacement upon time. Therefore, V is equal to displacement upon small t, that is V into t is equal to displacement. That means this incident wavefront moves from point B to C in time t and covers a distance V into t. Then during this time t, when the wavefront moves from point B to point C, during this time this point A acts as a secondary source of light and it emits the secondary waves in the same medium. And therefore, as the velocity is same, as the time is same, therefore each and every wave which is forwarding in these all directions in the same medium covers again a distance V into t, and all these secondary waves reaches at the semi-sphere of radius V into t. We can draw the semi-sphere of radius V into t as considering the point A as center, and therefore like this. This is the semisphere having the radius V into T. That means this wave which is progressing in this direction, it will move from A to this point, and suppose this point is called as D point. Draw the tangent to this semisphere from this point C, and this will be like this. Why we draw the tangent to this semisphere? Because when this incident wavefront moves from point B to C in time t, these secondary waves which are emitting from this point A, which act as a secondary source of light, they move from point A to D in the same time t and covers a distance Vt. Therefore, as the point P and Q are in the same phase, point A and B are in the same phase, in the similar manner, C and D are in the same phase by drawing the tangent to this hemisphere, and therefore this AB is called as the incident wavefront, whereas CD is called as the reflected wavefront, and therefore incident wavefront is converted into the reflected wavefront CD. Then in this case, this is the angle of I, angle P A M. This is the angle I, that is called as the angle of incidence. What is meant by the angle of incidence? Angle of incidence means it is the angle which is made by the incident ray with this normal MA. Normal means which is perpendicular to the plane surface or reflecting surface. Angle made by this incident ray with this normal is called as the angle of incidence. Then angle MAD, angle MAD, this is the angle of reflection, the angle between the normal and the reflected ray is called as the angle of reflection, and therefore this will be angle I, that is angle of incidence, and angle of reflection. Now we are going to prove the angle of incidence is equal to angle of reflection. This is the law of reflection. Then for this purpose, consider there are two triangles. Triangle triangle BAC and triangle DAC. These are the two triangles. Triangle BAC and triangle DAC. There are the two triangles in which the side AC is common. Length of AD, one side of a triangle, is equal to length of BC, second side of a triangle is the same. That means this side is same, these two sides are same, and both the triangles at this, the triangle ABC is right angle at point B, and triangle ABC is right angle at the point D. That means both are the right angle triangles having one angle of 90 degree and two sides are common, and therefore these two triangles are congruent triangles, or these two triangles are similar triangles, and therefore BC is equal to AD is equal to BD. Angle DAC is equal to angle ADC is equal to angle ABC is equal to 90 degree, and side AC is common. Therefore, if we consider the angle XAD PAM, this is the angle of 90 degree. As angle PAX is angle of incidence, and therefore this angle is 90 minus I. Angle PAX is equal to 90 minus I. Then angle MAD, this is the angle of reflection. Angle PAM, angle of incidence. Therefore, in this case, these two angles, angle PAX and angle BCA, these two angles are same. These are called as the corresponding angles, and therefore angle PAX is equal to angle BCA is equal to 90 minus I. Second, angle MAD is the angle of reflection, and therefore angle DAC is equal to 90 minus R. Angle MAY is equal to 90, therefore angle MAD is equal to R, and therefore angle DAC is equal to 90 minus R, and therefore angle DAC is equal to 90 minus R. As these two triangles are congruent triangles, these two triangles are similar, and therefore angle DAC is equal to angle BCA, and therefore as angle DAC is equal to 90 minus R is equal to angle BCA is equal to 90 minus I, and therefore R is equal to I. Therefore angle of incidence I is equal to angle of reflection. Angle of incidence, that is angle PAM, is equal to angle MAD. Angle of incidence is equal to angle of reflection. Thus we can prove the laws of reflection. Near about there are three laws of reflection. First, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. This is the first law of reflection. Second, incident ray, normal and reflected ray. Incident ray, normal and reflected ray are lie in the same plane, that is you can consider the vertical plane here. That means incident ray, normal and reflected ray are lie in the same plane. And third law of reflection, incident ray and reflected ray both are lie opposite side of the normal. That means if the incident ray lie left of this normal, then reflected ray lie in the right side of the normal. That means incident ray and reflected ray are lies opposite side of the normal. Normal means a perpendicular to the reflecting surface, and thus this is about the reflection of light, and we can prove that angle of incidence is equal to angle of reflection. Thank you.